All right, welcome to day 3. This is our first all remote day. Homework after this lesson will be packet page 45. Remember to take a picture of it, upload it to Schoology by 5 a.m. tomorrow morning. So do it right away when you're done with this. Do it later tonight. Don't leave it until the morning because it's due by 5 a.m. On your warm-up sheet, you should be on Wednesday. We want to find the 111th term of the sequence. Well, we always want to try and see what the pattern is that's going on. And notice these numbers are actually getting bigger, so we're adding. And each time we are adding 0.4 onto it. So that means our D is going to be 0.4. And if you're unsure your D, remember the way to do that is do the second minus the first. So in this case, we would do negative 4.8 minus a negative 5.2. That would become adding, which would give us the 0.4. So we go to our Regents reference sheet. Because we're adding, this is an arithmetic sequence. So we'd find our arithmetic sequence formula. Remember, we like to put that D in parentheses. We want to find the 111th term. So technically our notation would be A111. Our first term is negative 5.2 plus n, the term we're working with, is 111. And our D we identified as 0.4. So before we punch this in, let's just come up with a predictor. If we're adding 0.4 each time, these numbers are getting larger. So our answer should be something larger than negative 0.4. If you got something smaller, or larger than negative 4, I should say. If you got something smaller than negative 4, then you know that your answer is off. So when we punch this in the calculator, we end up getting 38.8. Okay, taking a look at your homework, we want to know if things are arithmetic. In 2, we were adding 10 each time, so that was arithmetic. In 4, we added 1, then 2, then 3, so that's not arithmetic. In 6, we're adding a negative 11 or subtracting 11, so yes, it is arithmetic. Your D is negative 11. And in 8, each time you either divided by 10 or multiplied by 1/10, that's not arithmetic. We want to find the 32nd term. In 18, recognize you're adding 7 each time, which is what tells us it's arithmetic. So use your arithmetic sequence formula. Your A1 is 23. We'll have 32 for the n, so 32 minus 1, and your D is 7, so you get back to 40. Really similar idea. In the next one, your D you have is negative 5. Putting in 32 for n, 9 is your A1, we get negative 146. Same process in 20, should have got 137. In 21, we're finding the missing term. So we want to find what is directly in between each of those. So we had a blank here. Remember, think of this as A1, A2, and A3. So our A1 is the negative 16. If A3 is 1, we know that n is 3, and the AN should be 1. So that's where this and this comes from, and then solve for D, get D is 8.5. When you add the 8.5 on, that gives us what's in the blank, the negative 7.5. And similar idea with each of the others. So you're putting an arithmetic mean in between. And then your explicit and your recursive formulas. Explicit, you're just filling in the D and the A1, and the recursive, you always tell what A1 is, and then what you are, your pattern is. In this case, we're adding 1/3. Now, if you're still unsure on any of those homework ones, you can always post a question on the content discussion board, and either myself or someone else will respond to and answer the questions you have. Oh, sorry, there was one more. We have A1 is 4 and we got D is 9. We want to know which term. So we don't know the term, so that means we don't know n is 184. So that means 184 goes in for the AN because that's the value of that spot. So I chose to do it by subtracting the 4 over and then dividing the 9 and then adding the 1 over. You could have also distributed the 9 and solved that way, but we would have got that it's the 21th term either way. All right, if you could flip in your packets to page 11, that's where we're going to start. And today we're going to focus on geometric sequences. So remember, a sequence, again, is a list of numbers with some type of pattern. And geometric, it means we're multiplying each time by the same value. And the value that we're multiplying by is what's called the common ratio. So because of that, we will use R to represent the number that we're multiplying by each time. Now, it might sometimes look like you're dividing each time, but in the formula for this, we need to think of it as multiplication. So if you're dividing by like 10, that's really multiplying by 1/10. If you're dividing by 2, that's really multiplying by 1/2. And where that comes from is way back in middle school when you did keep, change, flip. If you had a number divided by 7, you would write that as 701, and you changed the multiplication, and then you flipped. So that's why dividing by 7 is the same as multiplying by 1/7. So if you recognize it's division, just think about what would the keep, change, flip be, and what are you really multiplying by, and that would be your R. So 2 examples of geometric sequences. This one you're multiplying by 4 each time. This one you're multiplying by -1/4 each time. So our R value is 4 here. Our R value is -1/4 there. If you're unsure of the R value, sometimes it might be obvious, sometimes it won't be. We're multiplying, the opposite of multiplying is dividing. So you can always just do the second term divided by the first term to figure out what your R is. So here we could have done 12 divided by 3 to get the 4. Here we could have done the -2 divided by 8 to get the -1/4. Now the next 2 are not geometric. The first one's arithmetic. We're actually adding 2 each time. And then the last one is neither arithmetic nor geometric. We're going to skip the bottom of page 11, so you can go right over to the top of page 12. And on the top of page 12, you will see our Regents reference sheet again. The formula we'll be focusing on today is the geometric sequence formula, the one that is highlighted there, 4th one down on the right. So at the bottom of page 12, we want to find the 13th term of the sequence. Now today's day is all about geometric sequences, so that's a clue of what this sequence will be. But like on the test, you're not going to know what type of sequence it is. So let's imagine we didn't know. The first question we would want to ask is it arithmetic or is it geometric? Well, most people look for arithmetic first. It looks like we're going down, so we're subtracting. It looks like we're subtracting by around 500 in the first term. Okay, with 512 to be exact. Okay, but if you subtracted that amount again, it wouldn't give you 256, it would give you 0. So that rules out arithmetic, and that tells us we must be working with geometric. So for geometric, we need to know the A1, which we do is 1024, and we need to know the R. Well, remember, if R is not obvious, and it's probably not in this case, we do A2 divided by A1. So we'll do 512 divided by 1024, and that will reduce to 1/2. So going to our geometric sequence formula on the reference sheet, just like we put the D in parentheses, even though it's not on the reference sheet, I would suggest putting the R in parentheses. If R happens to be a fraction or a negative number, it needs to be in parentheses. That's why I would suggest to get in the habit of just always putting it in parentheses. So we want to find the 13th term, so we're going to do A13. Our A1 was 1024. Our R was 1/2. And our N is the 13 that we're working with. So all we'd have to do now is sub that in the calculator. Now I think it's good to make a prediction before you sub it in the calculator. We're getting smaller each time, so we need to know that we should get something smaller than 256 if we do this correctly. And when you punch this in, you end up getting 1/4. Next one, we're finding the 20th term in the sequence. So let's think arithmetic or geometric. Well, this is adding 3, then that's adding 4, so that rules out arithmetic. So this one must be geometric. Our A1 we know is 9. To find R, we can again do the second divided by the first. 12 divided by 9 gives us 4/3. It's bigger than 1 because it's growing. We'll use this formula again. So we're going to do the 20th term this time. So we have A20 is equal to 9 times 4/3 and to the 20 minus 1. Make a prediction. We're getting larger each time, so we should be something larger than 21 and 1/3. And when you punch this in, if you get a decimal, you'll notice the decimal doesn't terminate. So we would need to hit menu, number, approximate to fraction. And it's a crazy looking fraction. But this is actually the exact value of what the 20th term is. Okay, the geometric ones, when you go way down the line, they get pretty crazy pretty quick. Alrighty, let's go over to page 13. They tell us in this one we have a geometric sequence. They tell us A1 and A6. So let's draw out 6 blanks. So we know A1 here is 4, and we know A6 is 128 over 243. Well, because it's geometric, we know our formula is A1 times R to the n minus 1. Since they're asking us to find R, that means we should be able to identify all of the other things. A1 is easy. N and AN are the ones that you might get confused with. Well, N, notice, is the subscript of your AN. Our subscript here is 6. That means we're working with the 6th spot, and the value in the 6th spot is the 128 over 243. So remember, N will always, when you say it, it'll have like a TH or an ST or an ND. 5th, 3rd, 21st. Okay, a number like that, that'll tell you what the N is. We had the 6th spot. So our AN is 128 over 243. That's equal to 4 times R to the 6 minus 1. We're going to divide 4 over. I'm going to move over here. That'll give us 32 over 243 is equal to R to the 5th. Now, you may not be too familiar with how to undo a raised to the 5th. If you were raised to the 2nd, so squared, the opposite of doing that is the square root. So here, we will do the 5th root. Now, the 5th root on your calculator, if you hit Control and then the caret button, it'll give you a template for a root that you get to fill in what type of root it is. So you would just fill in the 5th root and then put in the 32 over 243, and you would get R is equal to 2/3. Now, just a word of caution, and this is our answer, by the way, because they just want to know what R is, but a word of caution. Remember, when doing even roots, so square roots, 4th roots, 6th roots, you would have to put a plus minus out front. Because when you raise things to an even power, it hides the negative, because if there was a negative there. So doing an even root, we're unsure if the original was positive or negative. Odd roots, it's just whatever sign it is. We had positive 32 over 243, so it's still positive. Moving down to the bottom of page 13, we're going to find a geometric mean. When you do a mean, it's just putting a number in between that makes it into a geometric sequence. So here's a kind of a simple one, 10 blank 1,000. The number that would have to go in the middle is 100, and then you're multiplying by 10 each time. So the technique for this is just to think of this as a geometric sequence already, where that's A1, A2, and this is A3. We know our A1 is 4, and then we get two pieces of information from that last term. The AN is 9, and the N, the spot number, is 3. So we can now use our geometric sequence formula, filling in our AN of 9, our A1 of 4, and we'll have 3 minus 1. So if we divide the 4 over, we'll get 9/4 equals r squared. And you undo a square with a square root, and this is what I cautioned about a second ago. Because it's an even root, you've got to put a plus and minus out front. Oops, plus and minus. So r is going to be plus and minus the square root of 9, which is 3, over the square root of 4, which is 2. Note this is not your final answer. R is just what you multiply by each time. So if you multiply 4 by plus or minus 3 halves, we just do 4 times 3 halves to get 6, and it would have the plus or minus in front of it. Okay, let's try one more like this that has more spots. 3 geometric means. A1, A2, A3, A4, and A5. So we know our A1 is 768. We know our N, the spot number we're working with, is 5, and the AN is 243. So we can use those to find R now. We've got our AN is equal to A1 times R to the N minus 1. Fill in the 243 is equal to 768 times R. And 5 minus 1 will give us 4, so I'm going to shortcut it and put 4 there. We'll divide the 768 over. And in our calculator, when we do 243 over 768, it actually reduces to 81 over 256. We'll take the 4th root of each side, which a big caution should be going off in our head, that we're going to need a plus minus. Remember to control and then the caret over on the left side. Fill in the 4 for the root. Put in 81 over 256, and that's going to give you 3/4. So we got to be a little bit more careful because we got lots of spots. So let's just do the positive 3/4 first. If we do 768 times 3/4, we get 576. Times another 3/4, we get 432. Times another 3/4, we get 324. And if we do it times another 3/4, that can check, and it does give us 243. Now we got to imagine we're multiplying the negative 3/4 through. Well, multiply by a negative, and the second thing could be negative. So we got to make that plus minus. But if you do a negative times a negative, that's positive. So this one can only possibly be plus, but then a positive times a negative could be negative again. So it could be that all of them is positive if you multiplied by positive 3/4, or if you multiply by a negative, it alternates the signs. So that's why only the first and the third blank could possibly be negative. We are going to skip the bottom one on 14. And we'll go on to page 15. They tell us A1 is 5 and A2 is 15. So, because it's geometric, we can tell that we're multiplying by 3. And if you're unsure of that, do the 15 divided by 5 to get 3. Well, A3 is pretty easy. Just do 15 times another 3. That's basically doing a recursive sequence, and we get 5. Well, to find A10, we've got to use our explicit formula that's on our reference sheet. we're going to have A10 is equal to our first term of 5. We know our R is 3, and we'll have 10 minus 1. Now, it's a good idea always just to predict. We know we should be bigger than 45 if we're multiplying by 3, and the last one we knew was 45. When we type that in the calculator, we'll get 98,415. All right, and our last one that we'll do, they give us the value of A1 and A4. So we want to find the value of A10. Well, they told us it's geometric, so we're working with this one. So to find A10, we need to know what N is, what R is, and what A1 is. They told us A1 is -1, so we're good there. The fact we're finding A10, we know that's 10. But we don't know R. So what we have to do is do one of our geometric ones with our spots to find what R is. So we can put 64 in for AN for a second. A1 will be -1, and we'll have R raised to the 4 minus 1 because 64 is in the fourth spot. If we divide the -1 over, we get -64 equals R to the third. Undoing a cubed, we do a cubed root. It's an odd root, so it's just whatever sign it originally was. When we put that in the calculator, we'll get -4. It is okay to do roots, odd roots of negative numbers. Even roots of negative numbers, that's when we have an issue. Like a square root of a negative ends up being imaginary. So we now know that our R is -4, and we can fill in with the 3 we want to find A10. So A10 is just our A1 -1 times -4 raised to the 10 minus 1. And when we punch that all in, we get 262,144. So it ends up being choice 2. So the big takeaways from today are knowing that geometric sequence is when you're multiplying over and over again, being able to identify the A1, the N, the R, and the AN, and then using the formula from your reference sheet. That's the main stuff from today's lesson. So you now have the homework for day 3 to do, which again was page 45. After you do it, take a picture, upload it to Schoology by 5 a.m. tomorrow. Have a great rest of your day.